Hi again. So, today I want to implement clause database reduction for my SAT solver. Last time I implemented restarts, and that and clause database reduction are two essential features to have an actually usable SAT solver. And I already went through the code and talked a bit about where I have to add things for clause database reduction. And one thing that I need to do is store more information about the clauses in the database to actually be able to decide which clauses I want to keep, which clauses I have to keep, and which I'm going to remove during reduction. And I guess the most important information is whether a clause is redundant or whether it is known to be redundant. It's kind of a bit inaccurate, the terminology that is used, because the solver partitions the clauses in redundant and irredundant, and that's actually not precise. Like it's not that if a solver considers a clause irredundant, that it actually is not redundant. It's just not known to be redundant. And initially, the input formula is classified as irredundant, and for now, it's going to stay that way. There are some techniques, some important techniques that can figure out that some of the original clauses are also redundant, but that's not something I have implemented yet or plan to implement today, or probably also not going to implement that soon. So to store additional data for clauses, I want to pack the information into individual bits of the data I store as part of the large buffer that contains all clauses. And in the past, I've looked at a few bit field or similar crates, and none of them really did what I wanted to do, even though I don't want to do anything complicated. But to me, it seemed that they were mostly concerned about parsing file formats or network protocols and similar things, and not accessing and changing individual fields as part of some data structure. And I've had a quick look at some newer crates that I didn't look at yet in the past, but as far as I could tell from a quick glance, it's still the same situation. So I'm probably going to do manual bit masking myself for that. So I'm going to do this. I guess I can just do, I might also just write my own proc macro for this eventually, if it's getting too repetitive and too tedious to maintain manual bit mask. So what I'm thinking of doing is to have something like redundant mask. Lit index is just a type alias for the type I use to represent literals. I'm not sure. So I don't think. I think there are a few places where the assumption that this is 32 bits will be hard coded. So it's probably not something where I can just change this type to 64 to a 64-bit integer and then have a solver that can work with more variables. But in any case, the memory, the required memory would get ridiculous if you go past that. But it still, I think, makes it clear that this is something that has the same, that is 32 bits because it has to be the same size as thing as used to store literals, which in this case it has to be because it's part of the what is it? Of the same buffer that also stores the literals of the clauses, and I want to make sure that certain bits are never set because the safety properties of my clause allocator depend on that. Okay, so and then this is the one thing that still always trips me off when I switch between some other language and then come back to Rust, that negation for integer types is, so bitwise negation is also done with the exclamation mark and not the tilde operator, which I makes sense given how things work in Rust, but still. Okay, so we mask it out and then do I just mask, or I think in the past I did it with a bit offset. I wonder whether this will always compile down to the most efficient way to do that, but it's probably not going to be affect the overall performance anyway. Okay, so I can store whether the clause is redundant. And now I need to make sure that I actually store the correct data for that. For that I have to go through the places where clauses are added. Tests. That can't be everything. It's also I think it missed this one. Anyway, right now there is no way to specify why a clause is added. And I think what I can do is to because I have this yeah, didn't find it because that I looked at the add clause for long clauses, but it goes via this add clause that depatches between binary and long clauses. That's how should I deal with that? So my idea was to just make add clause take a header, not a header, but just the data in the header. The header consists of the data and the length of the clause. But for binary clauses, I don't have any data. But I think there's no harm in taking the data anyway and just discarding it if it's a binary clause. Okay. That should the header. The header also needs to take the data. And not just create the default data. And then this is just passed through. And I need to fix up some tests here. I might actually at some point for these tests not use the actual solver clause data, but create an essentially empty or just containing test data, a structure containing test data, so I don't need to update anything in the tests when I extend the solver clause data, although it's probably fine if I just use the default values and even if more stuff is added. Okay, this is probably going to complain here now, yes. And so for the long clauses, the clause allocator is generic over the associated clause data. But for clauses, for the clauses struct that combines the binary long clauses and the watch lists, it's not, because this is just used for the solving itself. I plan to also use the allocator for the long clauses for some other tools, or even make it available for users of this library to store clauses, and they might want to store different data, but this is specific just for solving. So this is just the solver clause data. And yeah. Let's, huh. Why? I'm not sure if I caused this to be to use something different than what Rust Analyzer does by default when I import stuff, or whether the way it does this changed at some point. I should look into what it does automatically and then clean up everything so it also does things in that style. But I'll get to that at some other time. Now this should complain. I wonder, can I move this? No, to the side. Move panel left. Oh, right. Whoa. What happened? I pasted something. I kind of wish that that in Visual Studio Code that you could move the panels to an editor area and have it just as another tab, because that would be much more useful for the way I lay out things when I don't stream and use a smaller font size, but especially while streaming, because I don't want to block half of the screen permanently with this. But I also don't have something where I can, like, if it's at the bottom, it's also going to take up too much space if I don't hide it all the time. I think they're actually working on that, but that needs a lot of refactoring within Visual Studio Code, from what I've seen on the issues regarding that. Okay, so this is all the clause data. I might want to add some methods, like new input clause and new learn clause that set some defaults and then just update paths, but I'll do that as a cleanup later, or maybe even another time, when I have to refactor things, because I don't know everything that I need to set and at what point I need to do that right now. Okay, these are tests. So I think for these tests, it does not matter. It might start to matter if I want to test glue levels, but we'll see when I get to that. Okay, it's just the same thing. Where am I? Create clauses. So now I know which clauses I am allowed to remove. And the first thing, yeah, I missed this because the command line interface is in a separate. Oh, those are examples. I don't even need them anymore. Where are they? This can just go away. That was just some code I wrote for to temporarily test stuff before I wrote this still temporary but more permanent stuff to exercise things in the library. But this I still need to update. It just it's Rust Analyzer immediately updates stuff that's in the same crate, but I think sometimes it doesn't keep track of the dependencies between crates in the same workspace in a way that it would immediately flag errors that appear in one when you change the other. But it will do that as soon as you, I'm not sure when that happens, but it told me now. So this is an input clause, that's the default, but yeah, I think I should have methods to construct like input clause and learn clause. Because for learn clause, it's clear why I'm doing that if I set redundant, but if I don't change anything, it's just way too easy to forget to set something for whatever the reason is why I'm adding a new clause. And this way, at least the things that I at least have to make a decision of which of the few different cases of adding clauses this is. The tests that don't actually use this, I can keep that though. Okay. Um, so the simplest way to do some kind of reduction is to just remove all redundant clauses. That's still gives us a complete algorithm, as long as the restart interval is getting larger and larger. And I think for problems that are not very small, it's even going to be faster than not deleting clauses at all. So where's the database reduction? What's a good place for the database reduction? That's the usual problem when adding something new. And I kind of expect to get this wrong initially. And there also isn't... hi, Sam. There isn't too much... like, I cannot look at what another solver does, because they are usually not written in Rust and have different constraints on how they organize things. The reduction. I also started to reconsider whether the restarts I did last time are in the right place. But I kind of think the restarting and the reduction should be in the same place, or at least be scheduled from the same place, because they are kind of like if you would describe the solver architecture in a nested way, like with the core part and then parts around it, I would put them in the same layer. Even though I'm not sure if they actually should be a separate layer from the core solver loop or not. So which kind of data do I need for the reduction? I only need things to actually perform the reduction. I only need things that are in search. But for doing the reduction itself, I might need some additional data that's not needed during search. And reduction does a bit more things than restarts, so it's probably want to have a separate module for this. And I think I'm going to use the same pattern I've used for unit propagation and conflict analysis, of having a struct that takes a few references to things that are needed. But in this case, I think I'm going to take the complete search as a single reference. And then the data just for clause reduction, so separately. So this, and then This is something that I noticed that gets worse while I'm streaming. The things where you like the errors where you're thinking about something and you're already thinking further than you're typing, and if you're also talking at the same time, that's another thing you need to get in the right order. And okay, and then I want to have some reduce, which does things. And what does it need to do? So we take the long clauses and no, I want to and I already implemented something to iterate over the long clauses. And I need to right, so I have this cannot be an actual iterator because of lifetime issues. Because the thing I'm actually using, so it could be, I could have an iterator that iterates over the clauses as slices, that would work. And I can have an iterator that iterates over the clauses as clause references. But then to actually make use of the clause references, I would get into lifetime issues with the borrow checker, because the data that's used to step to the next clause is in the same buffer as the data that I want to access while iterating over the clauses. But with this while let, it's still quite readable. The resulting code is still quite readable. And I might want to I think I need to do I need to reborrow it, or does this happen automatically? It will tell me. So this is clauses. Actually none initially, but then while next clause. Yeah. No. Oh, it's not. Wait. Oh, because it's multiple levels deep. Yeah. Okay. I wonder, was there something I have to think about when I am removing clauses during iteration? Or did I write this in a way that handles that? Because I know for for implementing the in-place garbage collection, I needed to always advance the iterator before removing the clause. But I don't think I need to do that if I just delete something. Did I write a test for that? That would have been a good idea. Clauses, delete clauses, delete while. Okay, this does not delete things while iterating over it. But I can quickly write a test for that. Delete while iterating. But I don't need to store the references there because I'm going to iterate over that. And then what I'm going to do, if the literals, and the first literal is oh yeah, that's if it's odd, then I'm going to delete the clause. And because literal is actually the index is one below this, so it doesn't really matter. I just need to make sure that I test for the thing that actually should happen and not the opposite. So clause is left. And yeah, for this it would have been a good idea to keep this. And then if yeah, so I'm just going to use same test but inverted here, then I can't get this wrong. Then those should be the same. And that works. Great. Still not sure what I want to do with this panel. Okay, so we can ask long clauses for the data that is stored from clause, and then whether it is redundant, and if that is the case, we delete it. Yeah. This isn't quite something that's correct yet, though, because what can happen is that we are deleting a clause that is currently asserting. So the way that we are going to schedule reduction is that it can happen basically at any point during the search. So it's not something that is done just after a restart. In that case, this would most likely be okay. Actually, I'm just seeing, was the audio clipping a bit, or I tested it before, but I might have been talking not quite as loud as I'm right now. And where do I have the volume control? And I just saw that I was on the okay. I think it was peaking. The peaks were getting clipped, but it was probably just the transients and not. So it wasn't distorting things too much. Anyway, where was I? Okay, so okay, but that's good to know that I'm quieter then. I might have to adjust that at some point, but I'm not going to try tweaking anything during the stream, but I can do an unlisted stream and test this myself. Okay, so this can happen at any point during the search, and that means we have to make sure that we are not deleting any clauses that are currently part of the implication graph. So any clause that is currently the reason for an assignment that triggered a propagation in unit propagation that was not yet undone needs to be marked as don't delete me. I wonder if there's a name for this. I can't quite remember that there's an established name for protecting these clauses. So I think I'm going to call this bit for that protect for now, and if I see that there is some other name I should be using, then I will change it. So the way we can do that, at least one way, and the one I used in the past, is to just before collection iterate over the implication graph, mark all the clauses that are present there as protected, and then do that again after collection, after reduction, and reset that bit. Right. So that's stored in the trail, and steps that returns a slice, so I can use that. And if what type is this step? Reason is of type reason. So reason, if the reason is a long clause, then you take the data and set the protected bit to the value it should be, and this needs to be mutual. Okay. Now this should be something that's at least correct. Right now we don't actually have any data we store, and there isn't really any data that we store in between reductions, but there are some buffers needed that we can reuse. I'm not sure if it's going to stay this way, because reduction might be already infrequent enough that it's better to reallocate the buffers. For clause analysis, which happens after every conflict, that's certainly something where you want to keep and reuse the buffers. Here I'm not quite sure. Okay, so for testing, we need to call this at some point, and I said I want to have it at the same place as restarts. Now there's of course the counter that tells us that we basically the next thing of restart here. I'm not quite happy with the way the scheduling stuff turns out right now, but I'm going to just ignore my unhappiness about this for now, because I don't want to get stuck on that. But I need a counter to schedule that, so I think this is going to I'm going to rename this to schedule and then do both things in there, because this isn't actually doing the restarts. This and this is next restart. So change these things back. And I have a good use. And I think the reductions can be scheduled just every fixed interval of conflicts. So what year? 10,000, 1,000. So Why? Because the fields are not public. Reduce. Yes, this is reduce opts. Then it's completely correct that I was looking for this completion thingy. This might just work. Let's add some log message. And give it a try. It's probably way too aggressive in deleting clauses to. Let's take our restarts for and see if it finds a solution. But this might be a problem that really needs learn clauses. Okay. But yeah, so this actually isn't too bad. I think it was slower with just restarts and no reduction. Yeah, exactly. If both happen, then nothing is left, and that's bad. Well, you're right. The heuristics are left, but that could be enough for a satisfiable instance like this. But for an unsatisfiable instance, you need to have at least keep an increasing amount of learn clauses, or keep increasing the interval between restarts. But either of them alone is enough to get a complete algorithm. To get one that is fast in practice, you need to have the right trade-off between those. Let's try this with an unsatisfiable instance where we actually need to we can't get lucky with the heuristics, where we actually need to exclude the possibility of any solution. Wrong file format. While this is running, I'm going to look for a good reference for why it's still complete even if you aggressively forget all learned clauses. Because a few times when I was talking to someone, this came up, and a lot of people that you SAT solvers think you actually need to keep learn clauses. So having the exact reference for something that shows that you don't is probably a good thing to add at this point. If I can quickly remember where this was. Can't I find this PhD thesis? Okay, finally. That took a bit longer than so this is the thesis of Lin Tao. I'm not sure how to pronounce this. Let me look this up. This so I guess this is Lin Tao Zhang. This is the best I can do without having heard that. And in here is so is this the right part? So the idea is to keep for every decision level the number of variables assigned. So you have the variables that are assigned without making any assumption, and you can essentially have the sequence. And the idea here is it's done presented slightly differently here, but the idea is that the sequence, if you have lexicographic order on it, whenever you backtrack for conflict, that gets larger. It's not done using lexicographic order, but actually it's mapped to a single number here. But it's the same idea. And so when you backtrack, you might undo multiple decisions, because when doing conflict analysis, you don't just backtrack a single step, and you might even, after backtracking, have a different assignment than the negation of what you have just undoed, but you will have a larger number of propagations at that level. And because there is just a finite number of possible sequences, because you cannot assign more variables than there are per decision level, this must eventually terminate. And that's like the main point. I hope this was large enough. The proof for termination does not require the solver to keep all learned clauses. This value will increase no matter whether learned clauses are added or deleted. And also mentioned here that restarts actually, so if you combine this with restarts, then that's not true. But again, if the interval between restarts gets larger, that's fine again. Yeah, mentioned here. And I really need to save a local copy of this, because this comes up every time I'm talking about this. And yeah. Okay. So this works if we forget everything during restarts, but it's not a good strategy during reductions, not restarts. So now, how do we get a better strategy? Actually, let me first do a vip commit. Yeah, I think it's probably also mentioned in the handbook, but I'm not sure if there's if it does it present the argument for why this is the case. Because that's usually where the point where when I get into discussion with someone, so it's okay, yeah. It's usually that someone's, oh well, but practical set solvers aren't guaranteed to terminate eventually. So it's, on one hand, that's kind of moot point, because even if it's in theory would be a complete algorithm, it can still take way too long, and it will for enough problems. But then it often takes a bit of convincing that even if you don't learn clauses, and even if you do have restarts, as long as the intervals get longer, it is a complete algorithm. Okay, a better way to choose which clauses to keep and which to forget. We need to store some more data, and what I want to implement for that, what every solver since glucose implements for this are glue levels. Okay. I mean, I could also look it up myself, but which citation does it provide for that it's okay to delete all clauses? Easier argument is that one decision is replaced by a propagation. But even if you do the replacing, if you do non-chronological backtracking, it's, at least to me, it's not from just that obvious that replacing a decision by I mean, if you then so for me, what you're saying is either I can't follow it completely, or you end up with the same argument, but maybe presented slightly differently. If there's an actual different way to do this, to show this, I would be very much interested in that. And I guess, Matthias, you are probably the expert on proving that a practical SAT solver is complete. Anyway, I wanted to get back to doing a better job at choosing which clauses to keep. And for this, I want to compute LBDs, or glues. Okay. I'm not sure I have read either of those citations. But I'm getting distracted. I wanted to get back to this. So this was the thing that was introduced by glucose, and we need to store again more data for every clause, and that's the glue level. And the idea is that So as a very, very naive idea, one could say, well, clauses have different length, and if a clause is shorter, then it's more likely to propagate. So let's keep short clauses and delete long clauses. But in practice, that's not a very good predictor of how often a clause is actually useful. And glue levels or literal block distance, same thing, is a way that's a similar idea, but a slightly better predictor of clause usefulness. Where clause usefulness is, I think there are a few ways to make that more precise, like how often will a clause participate in a conflict in the future or something like that. But that's in any case something that we cannot know at the time when we learn a clause or when we want to do reduction. So we need to use something that we can compute as a proxy for clause usefulness. And the idea behind glues is that several literals in a clause are likely to be set at the same time. So I wonder, is there maybe it's a good idea to have a diagram for this. There's probably something in the glucose paper. Oops. This is not the paper I clicked on, and why did it open on this screen? Just the solver description. Predicting learned clause quality in modern SAT solvers. That should be it. So let's hope that there is. And the diagram I was looking for is not part of this. and I need to improvise. So the idea is if a clause is propagating, so let's say we have a clause not A, not B, not C, not D, not E, F, and we have an assignment that has on decision level 1 assigns A and C, and on decision level 2 some other variables, on decision level 3 A, C, B, D, and on decision level 4 E. Then this will propagate, this clause will propagate on the same decision level to F. And what's done then is to take the clause and partition it into the partition the literals by the decision level of their assignment. So 1, 3, 1, 3, 4, and 4. Oops. And then count how many partitions there are, and that's the literal block distance or glue level, or that are names that are used for this. It was introduced as literal block distance, but that's, I think just calling them clause glues or glue level is more common. And that also makes it clear that that's the thing that was introduced by glucose. There's always a thing that I can't remember. If you learn a new clause, then initially you will have a conflict, and that means you don't have this clause yet, but at somewhere you make the let's say the decision to assign F to false, and then conflict analysis might derive this clause. And at the time you start running the analysis before backtracking, this literal or the variable is assigned on decision level 5. And after learning and backtracking, the learned clause will be propagating on, and this will be level 4. And I'm not sure if all solvers always implemented this the same way, and if it's always described the same way. It's if you just compute this value for learned clauses at the time you learn them, it doesn't really make a difference, except that if you have some thresholds, you need to move them by 1. But then there's also the thing where you update the glue level of clauses that are involved in conflict analysis. I mean, theoretically, you could update the glue levels of every clause during propagation. I don't think that's done. Not quite sure. Sounds a bit too expensive. So I'm probably going to look at what I did the last time and do the same thing. So whether I count the scenario where I learn this clause from this situation as having a glue level of 3 or 4. That's kind of the question. In any case, I need to store it, and the glue level could be as high as the number of variables or one less, but in practice, at some point, it doesn't really matter. So we can use a few bits to store this packed together with some other data. I think I'm going to look up what I did last time. So I used 6 bits. I actually need the offset, but I think active is used. Yeah. So probably would call it used today, but apparently I called it active back then. I'm not too happy with this bit masking thing, as I mentioned before. It's also not aligned. This needs something to automate this. So I guess it will not be long before I write some proc macro that allows me to just do this like bit fields and see, or go through the libraries, the bit field libraries again, and maybe find some that does exactly what I want. But, there might not be one. Okay. Bitvec, that's a popular one, I think, but I think there was a reason for which crate called Bitvec. One just called Bitvec. Wait, I can look it. So does this do what I want? Please just show me some code. If I remember correctly, there was one called Bitvec, and then am I mixing that up with another one? So there are certain, so for Bitvec there's also non-Bitvec, which might be okay. No, that's just adds things. Yeah, there's one Bitvec crate, I guess. But there are a lot of crates that provide similar functionality. Okay, you can explicitly borrow existing scalars. That's nice. That's something that a few of those crates don't do. So this might just work. Let's look at the documentation. Okay, just from the examples, it's not completely clear to me how to use it. So is it just the manipulation, or is it also, does it have something to actually define bit field types? I'm perfectly fine with using it just to avoid writing masks or bit shifts manually. But if this does have something to define bit field types, I might want to use it. At least I don't see any examples that define types. And then the question is, how does it deal with endianness? Because if I remember correctly, last time I looked at a few crates, there wasn't really a way to say do things in native bit order for 32-bit words. Don't care about atomics. Bit order. Indian. Doesn't mention Indian here. MSP, MSP. Oh, that's a broken link. Oh, incorrect link. Ah, because it's a re-export. Within register type. Yeah, but this looks like something I can use, so thanks. So let's look at the example again. So this example here, you can also data from element. So can I do self and then just do oh, I guess I want to use local bits. bit ordering. Because one thing I need to make sure is that I don't set the most significant bit. Otherwise, I wouldn't care about this as long as it round trips. But I mean, these significant bit is relative to the actual integer value. And if this is using, so yeah, this should work. Still need to have some offsets, but that makes it easier to maintain. I guess that's then so those are bits 2 to now it's easier to keep them to keep consecutive ranges if I write this out. Oh, it's complaining. Which type does it need for indexing? So this is bit slice. And this should implement index usize. I think in the standard library, all the stuff that represents a bit count is using 32-bit integers. Oh, but this can probably this can also index into arrays of words. Then it needs to have users there. So I hope this also works. Is there bit slice? How wait a moment. How do I assign stuff? From slice. Is there also something like this for from element? Bit slice. Oh yeah, there's. Still not happy. Why not? Cannot assign data. required but is not I don't get it. Oh, I think it actually doesn't work. And it's probably so the index type, the index trader for us doesn't allow you to do something like this because you need to return an actual reference to whatever this is, and there isn't one. And now I'm really wonder how it works around this for indexing when it's read only. But I probably don't like what it's doing to do that, because it could, like if you're indexing and we want to return a Boolean value, you can return a reference to a global true and a global false value. And that gives you a nice API, but that might result in not that nice code being generated. And if I use get, I have to unwrap it, which is fine, but not that nice code-wise. So I don't like how that would look. How does this implement index? Return type after indexing. Return self. This returns bool. Let's look at the implementation. Yeah, and that's so this is a constant value, so it will return. Yeah, this might actually be optimized just fine. And there's every crate like this I've looked into, there's has always been something like this where I'm not happy with some detail. I think I'm going to go ahead with this for now, but I see myself replacing this with some macro to generate the kind of code I'd initially from just the bit field sizes. So glue level. What type to use here? That I use size. So what happens if I do this? Can I convert that? No. What does it return? It returns a bit slice itself. How do I convert a bit slice into an integer. So store. Does this load? No. I need to trade. Okay. This should be saturating. So this is the minimum of that, and 1 shifted by this way around. No. And then I can use store. Okay. Now I can get back to actually computing this. I want to have a look at what I did last time. What did I do? IBD. Glue. Compute glue. Where do I call this? Says learn clause and an bump clause. Okay, that's the way I did it. And when do I call this? Okay, and I only call this for long clause, which makes sense because binary clauses are separate. So it's again the question, how do I structure things? Where do I keep which data? So as far as I can tell, the only place where I'm going to use this is during conflict analysis. So it would make sense, if that's true and if that's going to stay that way, to have the the bitmap used to count the partitions as part of conflict analysis. This isn't really something where I can just do the same thing I did last time, because last time I used some, I would call it a hack, to get partial references in Rust where I can have like a single context struct that contains everything, and then list parts that are accessed. And this has made it easy to just do what solvers written in C or C++ do, because they can also just pass around a pointer to the main struct and then just have access to everything. But that's not something that works too well with the borrow checker. And so I have to figure out where to move things to not run into those issues. I might also just need a short break. Yeah, I think I'm going to take a break. I'm not sure if I'm going to continue today or another day, but yeah. So, overview. We have some kind of too aggressive reduction, but this is still on the to-do list. And that's something for next time, later today or probably tomorrow. So see you again next time.